Good morning, everybody. Before I go over what day 43's assignment is going to be, I just want to take a few minutes here to just review what we've gone over so far. So going back a few weeks ago, we started our unit on matter. So if you take a look at the screen that's in front of you right now, a few things we've learned so far is what matter actually is, the definition, which is anything that has mass and takes up space. We then classified matter as either a pure substance, a compound, or a mixture, and we looked at examples of each. So for example, gold will be a pure substance because it's made of only one type of element, gold. Sometimes when two elements combine together, they form a compound like salt. Salt is sodium and chlorine gas together, which makes a compound salt. And finally, a mixture. A mixture is when you have two or more compounds or two or more elements mixed together, like salt water, for example. You have water and salt. That's going to be classified as a mixture. So they are the three main classifications of matter. Moving on, we then learned about properties, and that's like a trait, how we can describe it. So there was physical properties and also chemical properties. And you can see some of the examples listed there below. We then discussed how we can observe changes in matter, how it can undergo a physical or a chemical change. And physical changes are just changes in size, shape, state, or form. So for example, when like an ice cube melts into a liquid, it goes through a physical change. Now, the reason why it's physical is because the substance's identity does not change at all. It's still water, even though it's a liquid form now. You can fold something, paint something, break something. If the identity is still the same, it's going to be a physical change. However, chemical changes, what we just wrapped up, are much different. Chemical changes are when the change results in the formation of a new substance. So, for example, if I take a match and burn it, the wood that's burning is no longer the same substance. It's been reduced to ash and also gas. So the chemical changes require chemical reactions. And we looked at some examples of chemical reactions. And hopefully on Monday and Tuesday, you did your cooking assignment where you had to cook something, which is an example of food undergoing a chemical change. If you made a cake, for example, you have all those ingredients, like flour, salt, butter, the egg, any other ingredients that you put in there, all separately. They are much different than when the cake actually cooks in the oven and turns into a nice, sweet, tasteful, cake. All right, you can't go back and get those ingredients back to where they were from the very beginning. So that's what a chemical change is. They are much different. Now, today, what you're going to do is understand how you can measure matter. So when we measure matter, we really look at three different units of measurement. That's going to be mass, volume, and density. So mass is really how much matter, how much is in something. For example, how much matter is in something, so you can weigh something on a scale. That's going to be the mass. And mass is usually measured in grams or kilograms. Volume is how much space something takes up, and density is the relationship between those two, mass and volume. So how is matter measured? Again, the definition of mass is what you see in front of you. It's the amount of stuff in matter, and that's usually measured in grams. And if you have a kitchen scale in your house, that's going to be used to measure grams. The volume, how much space something takes up, that's usually measured by a formula. So we might take the length, the width, and the height and multiply those three numbers together to get the volume of a box, for example. Sometimes you have pi d or pi r squared, whatever formula you're using to measure volume. Actually, that was circumference formula, correct me. All right, but the volume is usually given as a formula. And then density is what you're going to be working on today. Density describes how tightly packed together the atoms are in the substance. So for example, you take a ping pong ball and a golf ball. The ping pong ball is much less dense than the golf ball, because if you think about it, the ball or a golf ball has a lot more stuff packed inside of it, so it makes it much more dense. The ping pong ball is basically air inside. All right, so when we measure density, we take the mass of the substance and divide it by its volume. So there's a formula, D equals M over V, is what you're going to be using today. So today what you're going to do is you're going to go to Pearson and you're going to complete an interactive lab that is going to show you how to measure and calculate density. So make sure you do that today. I think there's 8 pages here, a couple different quick math problems that you're going to do to just see how the relationship between mass, volume, and density are understood. All right, and that's going to be what you'll be working on today. All right, email me if you have any questions, and good luck.